Okay, what's up guys? Today we're going through questions 1-1 through 1-10 in the Hebler Statics textbook for engineering statics, so let's jump right into this. So question 1-1. What is the weight in newtons of an object that has a mass of 8 kilograms, 0.04 kilograms, and C 760 megagrams? So these are actually pretty straightforward. First off, let's define a newton. So we need to find the weight in newtons. So in Newton, let's define the units here. Is a kilogram multiplied by a meter per second squared. So over here you can see we have the mass. We have the mass for all of these, so we need the acceleration. Weight is a directional force due to gravity. A force is a Newton. And the acceleration due to gravity, so this is acceleration. So all we need is that to find the Newton, which is the weight. So the acceleration due to gravity is actually equal to 9.81 meters per second squared. And then you can see we have this part of a Newton, and we also have this part of the Newton. So it's that simple, really. Once you know what a Newton is comprised of, then it's pretty straightforward. So 8 kilograms multiplied by our 9.81 meters per second. Whoops. That's going to give us an answer of 78.48 newtons. So pretty straightforward these. You just need kilograms, you need the mass in kilograms, and you need the acceleration due to gravity to find weight. And then we have B, which is 0.04 kilograms. I'll multiply this one a little different, just show different formatting. So that is horrible. I am so sorry. Excuse my airliner abilities here. I'm just learning. 9.81 meters per second squared. And this one's going to yield us 0.3924 newtons. Same as the first one. Not too bad. Then we have C. A little bit different, this one. So we have megagrams. And if we look at our metric prefix table, we can see a mega is 10 to the 6th. We need to convert this down to a smaller unit, so the number is going to get much larger by a factor of 1,000. We need to convert down to a kilo. So we're going from 10 to the 6th to 10 to the 3rd. So an easy way to do this is actually, let's put 760 over here. A very visual way if you're a visual learner. We're actually going to want to move the decimal 3 points to the right, because we're going down, the number is going to get larger. That's how you can think of it. If you're going up, the number is going to get smaller. If the unit's getting bigger, your number is going to get smaller. If the unit's getting smaller, your number is going to be bigger. So let's just say after the decimal here, we know there's a couple zeros. So 1, 2, 3. So that's how many kilograms we'd have. 760,000 kilograms. And that is what megagrams in the higher units are good for, like simplifying instances such as that. Not making it such a large, hard to work with number. So we multiply those out and we get 7,455,600 newtons. And then you can actually convert that down to a meganewton. So 7.45560 meganewtons. And all I did there was move the decimal 6 places to the left, because we're going up in units, so our number is going to get smaller. So meganewton, and a mega is 10 to the 6th, therefore we move the decimal 6 places. So these aren't too bad, pretty straightforward. Moving on, we have 1-2, represent each of the following combinations of units in the correct SI form. So without further ado, let's get on with this. I'll explain to you what SI form is in 1 second. So here we have a kilonewton over a microsecond. Basically, the easiest way to think about this when we have a top and bottom is we want to get the bottom to an absolute value. So here we want second, here we want newton, and here we want kilogram times second. Okay, we want the bottom at its absolute state, right here in between deca and deci. We want it at a 0 value. And then when we're multiplying, we're just going to simplify we're going to keep the same ratios between the units, and we're going to simplify the units overall. And you're going to see what that means further. You're going to see what that means in depth later on. So a microsecond, let's look here. We know micro, it sounds small, so 10 to the negative 6 right here if you look over here. So we can replace the micro. Basically just think about it, replace the symbol with this number right here, the multiplier. These are also multipliers. So 10 to the negative 6, we can just replace it. That's an easy way to think about it. And then killi, so we're going to replace it with 10 to the positive third. That's going to be newtons. And then I learned this in calc. I don't know if you've learned it or where you've learned it if you have. But basically when you bring up an exponent, when there's a number to a power and you bring it to the top, because we want to get seconds alone on the bottom, so we have to get the 10 to the negative 6 power to the top. When you bring this to the top, the negative 6 is actually going to become a positive 6. So it's going to be 10 to the positive 6, and exponents add together. So here we have 3 plus 6, and the 10 stay the same. 10 to the 9th newtons over seconds. And we know 10 to the 9th, if we look over here, is a giga. So a giganewton per second. And that's your answer. Easy way to remember this, if you know hard drive storage, you start with a byte down here, then you go kilobyte, megabyte, gigabyte, terabyte, petabyte. And that's how I easily remembered it to begin with, because I already knew storage, and they all go up by 3s. So then we have a megagram per millinewton. So we look here, mega 10 to the 6th grams over millinewton, and as a lot of us know, milli is 10 to the negative third. If we look here, 10 to the negative third. So once again, we want to get newton alone on the bottom, get this 10 to the negative third out of here, up to the top, add 6 plus positive 3, positive 6 plus positive 3, 10 to the positive 9th grams over newtons. And then once again, we know 10 to the 9th is a giga, oh, whoops, excuse me, I was looking at the top, a gigagram per newton. Pretty easy. Then we have C. These get a little harder later on, you'll see. Meganewton per kilogram times a millisecond. See if we can make that looks even worse. So a mega, 10 to the 6, positive 6 newtons. Then our bottom, we're going to leave kilograms the same. That's already in SI form. We're going to multiply that by our millisecond, which milli is 10 to the negative third. So here it works the same way. This has nothing to do with it. The distributive property applies here, so we can just move this guy right up. Once again, like the previous ones, 10 to the 6th newtons per kilogram seconds. Then one last step here, we have to get 10 to the 9th into giga. So giganewton per kilogram second. Pretty straightforward. Once you get the hang of it, it's not too bad. Okay, very similar to the previous. Represent each of the following combinations of unit in the correct SI form. So A, we have megagram per millisecond, aka mega as 10 to the 6th. Keep our grams. A milli is 10 to the negative third seconds, 10 to the negative third, and mega is 10 to the 6th. If we look over here, and then we're going to bring the 10 to the negative third up again because we want seconds alone on the bottom. 6 plus 3 is 10 to the 9th grams over seconds, and a very familiar unit by this point, 10 to the 9th is giga. So we have a gigagram per second. Easy. Moving on to B here, Newton per millimeter. The Newton is already in the SI form, perfect, that's awesome, makes our job a little easier. Then we have 10 to the negative third because it's a milli, keep our meter. Then we want 10 to the negative third up top, So let's just bring it up top because it doesn't add to anything this time. There's no summation. And this becomes positive, so 10 to the third newtons per meter, aka kilonewton per meter. And then we have C. C is a millinewton over kilogram microsecond. So we're getting a little bit, you can see how it's getting a little bit amped up here, but it doesn't get that bad, believe me. So 10 to the negative third newtons, because a milli is 10 to the negative third. Then we have our kilograms, which are already in SI form, multiplied by micro, which if you can see here, I may have micro. Let's put it down here. 10 to the negative 6 is what micro is. So 10 to the negative 6 seconds. And then this one's a little different. I'll show this one out for you. So kilograms is fine. We want to get the 10 to the negative 6 up to the top. We want seconds alone. So we want kilogram times second on the bottom. Then we want whatever comes out on top, but it's going to be a newton. So we bring 10 to the negative 6 up. So we have 10 to the negative third. And then we also have 10 to the positive 6 newtons per kilogram second. And then these add, so the sum of negative 3 plus positive 6 is positive 3. So then we get 10 to the third newtons per kilogram second. Then real quick down here, 10 to the third is a kilo, aka 1,000. You can also put 1,000 too. These are fine, but these are huge space savers when it comes to this, so that's why I'm using them. Kilonewton per kilogram second. Just like that. Not that bad. Again, you can do this with a fraction of the work. I just wanted to show it all, show the process. Okay, we have a unit conversion for 1-4. Convert 200 pound-feet to Newton meters. Okay, 200 pound-feet, and we want that to Newton meters. So let's get going here. So a foot, we're going to want that conversion. We know that in 1 foot, there are 0.3048 meters. Okay, so the feet cancel. Once again, with the unit conversions, you're going to want the unit you want to cancel out. One has to be on top, one has to be on bottom. So if I put feet on top here, then I would have pound feet squared over meters. Okay, that would make absolutely no sense. You have to have a in this scenario, I had to put feet on the bottom here. If I was to put meters on the bottom, this would not work out whatsoever. I had to put feet, the feet cancel, and this number, these two numbers, the top and bottom of your multiplier, these have to be equal. So 0.3048 meters is equal to 1 foot. So moving on, now we have pound meters, and we want Newton meters. So we're going to want to convert pounds to kilograms, so then we can get newtons. So there are 2.205 pounds in 1 kilogram. So then the ibs cancel, or pounds, excuse me, and then we have kilogram meters. We want Newton meters once again. So to get that final transformation, 9.81, which is our acceleration of gravity, meters per second squared, and then the kilogram multiplied by meters per second squared, that is a Newton, and these all work out fine. The Newton ends up on top, it's wherever the kilogram is. So we have Newton meters, and then those all multiply together, yada yada yada. Wow, it's bad parenthesis. That's going to equal to our 3 significant figures, like the problem states. I don't know if I stated that. 271 Newton meters. Okay, and then we have B. You're going to notice some of these conversions are going to get very repetitive on these. So 350 pound foot cubed So this is going to be familiar. We're going to do meters once again. So 1 foot is equal to 0.3048 meters. Now did you see how this time I put foot on top? Or feet, however you want to say it. This is a foot. Plural is feet. But I put the foot on top. That's besides the point. This is not English class. I put the foot on top, right? And this is because it is opposite the foot on the bottom. You have to have one on top and one on bottom for them to cancel. That is critical when doing this. I cannot put the meters on top. So here I have a cubed. If I was to cancel this, this would still be squared down here, so it'd work out like this. We don't want that. So what we actually have to do is cube this whole thing. And then this is cubed. The meters are cubed as well. If you notice, we want meters cubed. So the feet are cubed, the meters are cubed, everything's happy. So then this cube right here can cancel with this cube, and it all works out dandy. Then we have meters cubed. And what we're trying to get it into is kilonewtons. So we're stuck with pounds still, so we want to change that. So once again, 2.205 pounds is equal to 1 kilogram. Okay, and then we're kilogram per meters cubed. We want kilonewtons, so then multiply by 9.81 meters per second squared. And then these three guys are going to give us our Newton. And then, since we can assume a Newton is on the top, we could say 1,000 newtons, okay? Because a kilo is a much larger unit here. So we can say, because we're going down here, so our number is our unit is getting smaller, so our number is getting larger. That's how that works. So we're going to say 10 to the third newtons is equal to 1 kilonewton. Okay, now don't be confused. This, wherever the kilogram is here, when you're multiplying by gravity, that's where the newton is. So these will cancel. So watch. This cancels. That's a newton. This cancels. We're left with kilonewton per meters cubed, which is exactly what it wants from us. And there are 10 to the third newtons in 1 kilonewton because it is 10 to the third larger. So our number is going to be 10 to the third smaller because we're going up in unit size. When you go up in unit size, the number gets smaller. When you go down, the number gets larger. So then you, let me see if I canceled everything. Yes, I did. Then you just multiply out and divide on your calculator. You get 55.0 because we're going to 3 significant figures. Kilonewtons per meters cubed. Bam. Finally, we are on C, copyright. And here we have our 8 feet per hour. We want to get that to millimeters per second. And if you're wondering why I'm putting parentheses around this, it's because they're all multiplying. And on top of that, it's also just to keep it organized. Instead of, it's easier than a dot in my opinion. It looks nicer. So let's convert time first. So an hour. So in 1 hour, there are how many minutes? There are 60 minutes, right? We're converting this to seconds. So there's 60 minutes in 1 hour. I put hour on top to cancel with the hour on bottom. These were equal. And then 1 minute, there are 60 seconds as well. So 60 seconds. And then I put the minute on top because the minute on bottom, they cancel. Now we have seconds on the bottom still, which is perfect. That's always going to work out that way. So whatever you start with, this time is always going to be on the bottom here, and the distance is always going to be on the top as long as you follow the correct conversions. As long as you do one on the top, one on the bottom every time. If not, things will get very wonky. And we want millimeters. So once again, 1 foot, 0.3048 meters. And then our feet cancel. And now we're in meters. We want millimeters. So in 1 meter, now look, our units are getting smaller, which means our number is going to get larger by a factor of 10 to the third. So 10 to the third millimeters. These are equal to each other. 1 meter and 10 to the third millimeters are the same thing. Because if you go right here, milli is 10 to the negative third. So if we go up by 10 to the positive third, 1, 2, and then 3, we're in the middle. Boom. So our meters cancel. Everything cancels and we're left with millimeters per second, which is exactly what it asked for. Then we get for our final answer, 0.677 millimeters per second. Pow. Okay, question 1-5. Represent each of the following as a number between 0.1 and 1,000 using an appropriate prefix. So by appropriate prefix, it just means one of these to the third. One of these by a multiple of third. By multiple of 3, excuse me. So A, this one is quite simple. This whole question is quite simple. So 45,320 kilonewtons. We're gonna want to get that in newtons. We want to make all these family friendly in between 0.1 and 1,000. So let's convert that guy. So this is a pretty big number already. And it's in kilonewtons, but we're still gonna have to go up in units, because when you go up in units, the number gets smaller. So let's try mega. So we're gonna get a factor of 1,000 less. So let's factor out 1,000 using the little decimal method. 1, 2, 3. We go over 3 places. Then we're left with 45.320 meganewtons, which just so happens to fall in our range, which is perfect. I think that was the only one you could have used there. No, it actually isn't. You also could have converted it into giga, I believe. And then we have B, which is 56.8 10 to the 5th. So basically we're just going to tack on 5 zeros because we're going to move the decimal 1, 2, 3, 4, 5. 3, 4, 5, put our commas, big number. And that is millimeters, so it's a very small unit, so we're definitely going to want to make the units larger. So we go milli, then let's just go to meter. So now we're up by a factor of 10 to the 3rd already. So that's 3 decimal places. Another 10 to the 3rd, and that looks pretty good to me. So that's 6 decimal places. So 1, 2, 3, 4, 5, 6. Now we're at 56.5 or 56.8, excuse me, kilometers or kilometers, and that's within our range. Boom, looks good to me. Is there anything else you could have used? There are a couple others you could have used around here. I think hecto and deca. I'm not sure if it. I don't think it wants those. I think it only wants 10 to the 3rd for these. A power of 10 to the power of 3rd, or a power of 3. So 0.00563 milligrams. So this is a small unit, and this is still too small. So we're gonna make this even smaller. We have to go down to micro. So our units are gonna get smaller. The number is gonna get bigger by 10 to the 3. So that's 3 decimal places. 1, 2, 3, and that looks perfect to me. So 5.63 micrograms. And yes, these are all in our range of 0.1 and 1,000. And I don't think there's any other number you could use for that one. No, there isn't. There isn't. Not within the 10 to the power of 3 range. So now we have 1-6. Round out the following numbers to 3 significant figures. I hope this is review from other classes. I hope all of these have been review pretty much. 58,342 meters. And we have to get that to 3 sig figs. So 58, that's a given. And then we look at our 3 and our 4. Is the number past our 3rd number? These are all significant, by the way. We have 5 significant figures here, so we want 3. So this is where we make our decision. This is our last significant figure. Does this round up? Is this equal to or greater than 5? This is a 4. No, it is not. Therefore, we have a 3 here. And because we only want 3 significant figures, we don't know the next 2 numbers, so we're just going to put on 2 zeros. And no, those are not significant unless we put a decimal. Once we put a decimal, that implies that we know these by heart, by fact, to that point. We know that the next 2 numbers after the 3 here are zeros. That's what that means. Here it means we only know this far. We don't know these numbers. But once you put the decimal, it says there are zeros after that 3. So that's going to be in meters still. And that's 3 sig figs, like I explained. Then we have our B. And I'll also go into further explanation on this one, because I know this one's going to be a sneaky sig fig as well. So 3 sig figs, 6, 8, we know that. So does our 5 round? Does this guy round? No, he does not. 3 is not equal to or greater than 5, so this is still a 5. And then you're thinking, this is 5 sig figs right here too. Right now we have 3 sig figs. If I was to put 2 more zeros on, which some of you may be thinking, those would be significant, because that is implying we know the 100th place and the 1000th place past the decimal point here. That's what that is implying. And quite frankly, we don't, because we only know 3 significant figures. So, bam. We're going to stop right there. That is 3 sig figs. More zeros, once again, trailing zeros past the decimal point are significant. It's implying we know those numbers are there. Therefore, they are significant. So 2553 newtons. This one's very easy. So 2, 5, and then does the 3 round the 5 up? And so another 5, and then our 0, because we want 3 sig figs. No decimal there, because that would make 4 sig figs. And then we have our D. That's going to be 7,555 kilograms, aka 7.5. And then here we're going to do some rounding action. Our 5 is going to become a 6, because this 5 is equal to or greater than 5. Therefore, it's going to round this guy up. This is going to become a 6, and this is a 0, because we want 3 sig figs. Units are all the same on all these as they began. Not too bad. That one's pretty straightforward. 1-7, represent each of the following quantities in the correct SI form using an appropriate prefix. So basically, we just want to make these family friendly. We want to center these around the decimal, and that's pretty much it. And it's got to be in the correct SI form. So A, I'll show you what I mean on this first one. 0.00431 kilograms. The best way to describe solving these is just making the number originate around the decimal point. Okay, this is absurd. Why would you want this hard to work with? This unit is way too big for this number, because this number is extremely small with this big unit. So we're going to change the units here and turn it into correct SI form. So this is a pretty large unit, so let's make it a lot smaller. Let's make this a gram. So to make it a gram, a smaller unit is going to make the number larger. A gram is 10 to the third smaller. It's right here between these two. So then we move the decimal 3 places to the right to make the number larger. 1, 2, 3, 0.431 grams. And there we go. Now that's a lot better to me. That looks a lot easier. Then we have B, which is 35. And then our decimal starting here, and it's 10 to the third, so we're already going to move these guys over. So it's going to be a 3 here. Then our decimal's already moved to 1 place, so then 2 more, so only 2 more zeros, not 3. And that's newtons. So it looks like to me this is going to have to become a kilonewton. This is a lot of newtons. So it's going to be a larger unit, to the third larger, 1,000 times larger. Move the decimal 3 places to the left, because the number is going to get smaller because it's a larger unit. 1, 2, 3. 35.3 newtons. Or excuse me, kilonewtons. Gotta sneak that in there. Then we have C, last but not least. 0.00532 kilometers. And this is, once again, just like up here with the kilo here and the kilo here, these numbers are way too small for the units that they're given. So let's make this a meter. So it's going to be 10 to the third smaller unit. So the number's going to be 10 to the third larger. That's 3 decimal places to the right. 1, 2, 3, 5.32 meters. Wham bam. 1-8 now. So this is like the ones previous. Represent each of the following combinations of units in the correct SI form using an appropriate prefix. So let's start with A, like always. So we have a megagram per millimeter. So mega, if we look over here, I'm going to do some refreshing now, in case you forgot from the first part. 10 to the 6, we can just replace, then basically just look at the symbol. Okay, so M, big M is mega, little m is milli. So big M, we look at our symbol, we just replace it with the multiplier. So 10 to the 6th, keep our units, our gram. Then milli, we look down here at milli, and we get 10 to the negative third, little m. 10 to the negative third millimeters. This is meters, this is grams. So our unit's going to come out to gram per meter, some sort of something like that. We want to get the bottom value at just a meter. So we're going to move the 10 to the negative third to the top. And when we move exponents to the top of a fraction from the bottom, if they're negative, it's going to be a positive. And if they're positive, it's going to be a negative. So in this case, 10 to the negative third is going to become 10 to the positive third. And these exponents add because they, in their base number is the same, which means they can add. So the exponent's going to add, and it's going to be 10 to the 9th grams per meter. And 10 to the 9th is going to equal a gigagram per meter. A giggity gram per meter. See, 10 to the 9th, and that's our symbol. Bam. And moving on to B, we have a millinewton per microsecond. So a millinewton, that's 10 to the negative third newtons. Millis down here, 10 to the negative third. Replace the little m with the 10 to the negative third. Then a micro is micro, 10 to the negative 6. 10 to the negative 6 seconds. So we're going to move the 10 to the negative 6 up top. I'll show this one out just so I can explain it better. So 10 to the negative third, we're going to leave that guy. We're going to move this to the top. So a negative becomes a positive, and a positive becomes a negative when you move them up like that. So 10 to the positive 6 newtons. And that's all over seconds because we wanted to get seconds alone. And then these add. And negative 3 plus positive 6, the summation of that comes out to, hope you know, it's positive 3. So then we have 10 to the third newtons per second. aka I'm going to squeeze this in here, kilonewton per second. And if you don't believe me, look right here. 10 to the negative, 10 to the positive third, excuse me, 10 to the positive third. See? Micrometer, oh, not over, multiplied by a megagram. So here, kilogram is the SI form. So we're just going to manipulate meter around that. It's going to have to suffer. I'm so sorry, meter. So if you don't understand what I'm saying, just watch. So we replace the micro with 10 to the negative 6. This is just like the dividing problems, really. Then mega, we want a kilo right there. So we're only going to move down to kilo, and just that. So we're only going to move by a factor of 1,000, 10 to the positive third. So 10 to the positive third kilograms, and this is a meter right here. Then these guys cancel, so that cancels, and this cancels, and it becomes a 10 to the negative third because only 3 of them canceled. We added these together. Basically, just look at it as adding the powers. Negative 6 plus positive 3 equals negative 3. So then we have 10 to the negative 3. I'll write this out one more time. Multiply by kilogram. And then 10 to the negative 3, if we look over here, a milli is 10 to the negative 3. So our final answer here, millimeter multiplied by kilogram. In correct SI form. Okay, 1-9, represent each of the following. I'm not going to read that out again, we get the point. We're going to represent in SI form. Meter over millisecond. So meter is awesome, that's already in, that's perfect, no units around that. Then millisecond, 10 to the negative third seconds. A milli down here. So then we have our meter, or do we? Because we're moving 10 to the negative third up top. And when we move that up top, it's 10 to the positive third, and then 10 to the positive third is a killi, so kilometer per second. Easy. On this one we have 4 to solve for. That's just fantastic. So micro here, we have a micro kilometer. Just when you thought it couldn't get any more pointless. So then we have a micro down here, 10 to the negative 6. We have a killi over here, 10 to the third. Then we have our meter. And like the previous problems, our power is going to add together. So negative 6 plus 3 is negative 3. This cancels, and we have negative 3. And 10 to the negative 3 meters is milli. So our answer is millimeters. So that overcomplicated pile of junk came out to millimeters. And then we have C, which is a kilosecond per megagram, or milligram, excuse me. So remember what I said before. This one could stump you. The SI form for a gram is a kilogram. So we're not going to convert this to grams. This is actually much smaller than a kilogram, which is what we want it in. So a kilosecond, so that's 10 to the positive third seconds. And then we're going to want to convert this to kilograms. So let's look at milli. We're going to go up here, and we just moved it 10 to the positive third. We're going to move it again, and then we're at a difference of 10 to the sixth. So that's actually going to be 10 to the negative sixth, because we're moving up units, becoming smaller or larger in the prefixes, making our number smaller. So 10 to the negative 6 grams. And like previous problems, we want to get this guy, or kilograms, excuse me, this is kilograms. Like previous problems, we want to get this guy to the top. So that's going to become 10 to the positive 6. And 10 to the positive 6 plus 10 to the positive 3 is 10 to the 9th seconds per kilogram. And then 10 to the 9th is giga. So gigasecond per kilogram. Would you look at that? So then finally here we have a kilometer multiplied by a micronewton. That's a D. Kilometer micronewton. So Newton, we're going to want to get, once again, the meter is going to be left in the dust. It's going to become whatever it becomes. And we want to get Newton to Newton, because that's the SI form. So 10 to the third meters multiplied by a micro is 10 to the negative 6, so negative 6 newtons. Then these two are going to cancel out, so this is going to cancel out. This becomes negative third. But we want to get newtons as a newton. That's the SI form here. We want Newton as a newton. So we have our newton multiplied by our meter. Should have wrote this a little better. Then outside we have 10 to the negative 3, because we can do that. So it doesn't matter which one it multiplies by. It's going to be the same answer anyway. This is the distributive property, I believe is what it's called. So it can either multiply by, it can either be part of the N or the M. It's going to be the same answer either way. So we're going to make the M. Newton multiplied by 10 to the negative third is a micro, or a milli, so millimeter. And I'm not sure how many different forms you can put this one in. I know this was the answer key, but you might be able to do millinewton per millinewton meter as well. I'm not sure. I'm pretty sure this is the correct format though. This is what the answer key was, and this is how I solved it the first time. So moving on, represent each of the following combinations of units in the correct SI form. This is so repetitive. 1-10. So A, we have a giganewton multiplied by our micrometer. So this is one where we're just going to simplify this and basically get in this is very complicated. We're going to get it in a nice fancy format. So giga, 10 to the 9th meters, multiplied by a micro, which is 10 to the negative 6. Oh, this is newtons and this is meters, excuse me. So then we're just going to cancel. So 10 to the negative 6 cancels, and this becomes 3. Then we have kilonewton per meter. And once again here, I'm not sure if the kilonewton has to be a kilonewton, or it could be a newton per, or Newton kilometer, excuse me. I'm not sure if it has to be one or the other, but this is what the answer key says. And that's what I got the first time and this time. So kilogram per micrometer. Kilogram's perfect. We don't have to do anything with that guy. So kilogram per micro's 10 to the negative 6 meter. By the way, in case you haven't been watching, this is where I'm pulling this from. Look down here, see the symbol? Just replace the symbol with the prefix, and a kilogram is already SI form. So then we're going to move 10 to the negative 6 to the top, and that's going to come 10 to the positive 6. So 10 to the positive 6, and then a kilo. Let's take out the killi too here. So let's do 10 to the third grams. So that was a kilogram is right here, 10 to the third, and then our micro. So this is meter. Add the 6 and the 3, and then that gives us 10 to the 9th, which is giga. So gigagram, wow, that was bad, per meter. And then we got our C, which is Newton per kilosecond squared. So Newton, that's already fine, that's perfect. And then we have our kilosecond squared. So just to conceptualize this, let's leave the square alone for a second. So let's take the killi out. So 10 to the third seconds squared. So our squared, when an exponent is to a power, so when a power is to another power, basically they multiply. So this is going to be 10 to the 6th, and this is going to be seconds squared, because the unit is also being squared here. So it's going to be a Newton over 10 to the 6th seconds squared. Then we're going to move 10 to the 6th up top. It's going to become 10 to the negative 6th, which is a micro, as you can see right here. So the answer is going to be a micronewton per second squared. Bam. And we have D, kilonewton per microsecond. So a kilonewton, killi is 10 to the third, then our unit there. Micro is 10 to the negative 6, then our seconds. We're going to bring 10 to the negative 6th up top, and that's going to become 10 to the positive 6th. Here, I'll write this one out. 10 to the third, 10 to the 6th newtons per second. Add the 3 and the 6. The sum of those is 10 to the 9th newtons per second. And then 10 to the 9th, as we can see up here by giga, is going to be the big G. So the big G over seconds. Okay, thank you all for watching. I hope this really helps. Please comment, tell me what I'm doing wrong, tell me what I'm doing right. Subscribe, leave a like if I didn't already say that, and I hope you have an awesome day. Thank you.